Give again another example of transformation of a random. In this function, let us consider another function, which is absolute value, and assume that x is normal, and we want to find the distribution of y. So if I plot this function, I will get a V shape because absolute value of x is defined to be positive x if x is positive, and if it is equal to minus x if x is negative. So the second assumption of the problem says that I have a normal distribution with mean 0 and variance 1, and I have the PDF. Now we want to find the PDF of the transformation. So one way to do that is to write Fy of y is equal to probability that y is smaller than or equal y, and this y is absolute value of y. So what that means, if absolute value of y, absolute value of x is smaller than y, it means that x should be between minus y itself or plus y. Obviously, this is for the case that y is positive. If y is negative, this is equal to an empty event, and therefore its probability is 0. But if y is positive, this event is equal to this event. Okay, so this event, which is equal, and then probability of it can be calculated. So probability of this is the CDF at this point minus CDF at this point. Because you have equality here, you put a minus sign here. So this equality imposes this guy. Now you can calculate derivative of these. Obviously, if you write it, because for negative values of y you have 0, so you could multiply by unit step function, and here you have because of your symmetry of your distribution, you could write it twice fx of y minus 1. So you have this expression for this example. If you calculate derivative of this with respect to y, you get derivative of these times these plus derivative of these times this one. Derivative of this is twice fx of y times y, and these times derivative of unit step function is delta. So if you put x 0, this guy is 0, so this term will disappear, and then you get this one. So what you get as your distribution, you get the same distribution but twice here. So whatever distribution you had here, you will have here, but here you get 0. So this means that all the masses of probability that was negative becomes to positive value, because this is why you get twice of the distribution here.